Yes, good evening, everyone. This is drone webinar number two. Today we're going to dive into how do drones or how can drones improve the maintenance for better performance. So today's title will be improved maintenance for better performance using drone technology. So to start, we can start by first exploring what is the main purpose of or the objective of this webinar. So the objective number one is to improve preventive maintenance by incorporating drones inspection technology, but also preventing unexpected shutdowns and manage maintenance resources. First and foremost, we start by putting forward the main purpose of performing maintenance in every facility that we may have. It can be a plant, a production plant, processing plant, packaging plant, or just a storage facility. So the purpose of maintenance, first of all, is to maintain or improve the lifespan of the instruments. That is to make them last longer without having any major failures, but also to have a reliable system or instruments so as to avoid shutdowns and losses that may occur due to shutdowns. But optimizing the running costs is one of the key advantages of performing maintenance in our facilities. So those are the major, among others, purposes for performing maintenance in our facilities. But also, maintenance can be categorized into or classified into different aspects or classes. But there are two majors. One is preventive maintenance, and the other one is corrective. So, in general, the preventive maintenance it is all about performing maintenance before any instrument failure has occurred. While the corrective maintenance, you do maintenance after failure has occurred. So in each element, there are specific types also. Like for example, preventive maintenance, we have time-based, failure finding, risk-based, condition-based, and predictive. Yeah. So you find, for example, in time-based, maybe after every 1 month, you have to maintain a particular instrument. Maybe it can be a pump or a motor, or it can be a separator. Yeah. Or for example, risk-based, you find an instrument which, due to its failure, when failure happens, what types of consequences that it can cause. So the ones which has very high level of risk, that's the one which we monitor it very closely. But also condition-based, you have to check what's the condition of each instrument in your facility. The one which has far worse conditions, the one which you put much resources on. And predictive, it is to look for any simple ambiguities in instruments. For example, loose screws, so you tighten them before they cause any further damage or failure. So in nutshell, that's how maintenance it is. So, but now where do drones fit in all these two categories of maintenance? Drones, the main comes when it comes to preventive maintenance. That is, before any failure has occurred in the system, that's when drone actually can benefit a user or an operator during maintenance. That is, there's no failure, so you use drones to monitor the condition of the assets to see which one has likelihood of failure or which one has new developed features so that you can go and correct them. So drones are mainly used during the preventive maintenance so as to identify the problem in its early stages. So you deal with them before any major catastrophe has happened. But also using drones, you can monitor the progress of instruments, any changes that may occur, any rate of failure, for example, corrosion or vibration, and what are the causes to those failures. That there is where the drone actually comes in. Of course, later on we are going to to see the use cases of drone. So now, what are the advantages of incorporating the drones in the maintenance? Number one, as I said before, it is early recognition of problems. That is using drones. In our first webinar, we saw the type of sensors that we put in the drones. So most of them they can detect early stage problems when they are rising. For example, through the thermal camera, you can see that there's some sort of leakage, even in a very initial early stage of the leakage or the welding failure. Or, yeah, we have the sniffers, which they can detect any form of leakage in a system, maybe gas leakage. So using the drones and the sensor, you can detect this problem early in their arising stages. But also, we eliminate unnecessary shutdowns because if you don't attend to these signals which we get from data collected by drones, then you end up having shutdowns, which is not good for production. It causes losses due to shutdowns. But also, drones, when used with maintenance, they help in managing the resources that instead of allocating resources in each and every facility, you first see using risk-based maintenance approach. You see which facility requires the fast, immediate response compared to others. So you first analyze the risk of each uh, catastrophe or failure, then you assign specific resources to that facility so that it can be rectified. But also cost savings because using drones, you don't necessarily need a huge number of people to inspect these facilities now and then. Just one drone can inspect the whole facility in some hours. So in each week, you can use few hours to run the drone and inspect the facility. But also as drone accumulates a lot of data, it is easier now for you and the team to sit down and have a data-driven decision making for maintenance that we are proposing maybe facility A is the one which has to gain more focus. Why? Because we have a lot of data. There's a lot of failure which is predicted to happen in the near future. Yeah. But also drones in maintenance they enhance safety because there are some facilities that there's exposure to chemicals. So we can't send people there a lot most of the times. If we have to send them, then there must be a shutdown. You see, but using drones, you can just anytime you can send the drone without being afraid of to compromise safety of the facility or the workers. Yeah, so these are some of the advantages that we have once we have drone as addition to a complementary asset to maintenance plans. So we're going to see some use cases for the drone. How can they be used for maintenance and how can they determine the failure in the instruments or in assets? So number one, we have solar panel inspection using drones. So as you can see here, we are using the thermal camera to inspect the solar panels. Now, this is a huge field, for instance. So once it happens, a failure, maybe you will notice a drop down in the maximum power produced. Then you start asking yourself what the problem is. And to diagnose all this field of these panels manually, it is going to be cumbersome and time consuming. So, but using the drone and thermal cameras, it is easier now to identify the defective cells at each individual panels. So after the inspection using drone, the drone will tell you the specific area and the number of cells that are defective. So, and the way this identifies the failure is using the thermal image, where you get the different heat signatures from different cells. The ones which are working, as you can see here, the blue ones, but the ones which are red and yellow, they show a high heat signature, meaning that they are defective compared to the others. So that's one of the use cases. So using a traditional method of inspecting each solar panel will take much time, and also you might not find where the problem is. Yeah. But also, we have transformers inspection using drone technology. Yeah, using the same sensors, the thermal and also the RGB cameras, we can know what's going on inside the transformer, which by naked eyes you can see, or you have to shut down to cut off the power from the main grid and start diagnosing the problem. But using the drones, actually, you can start having the initial data on where the problem is. For example, in the inside the transformer, we have the cooling fluids, which they help to maintain the temperature, the optimal temperature of the transformer. So once you see that there's different heat signatures from the image, that means part of the transformer is not being cooled properly. So maybe there's some issue with the cooling fluid movement inside the transformer. But also you can also identify the any issues with the windings or coils inside the transformer, such that some of the coils are hotter than the others. So you can know that there's some maybe not current the transformer might be working, but in the near future there's a risk of failure. But also we have the grid lines inspection using drones. Now for this one, yeah, because we know the right of ways can go hundred of kilometers, yeah, without closer supervision. So using drone, you can inspect all that area in one day or even less than one day. And with this inspection, you can identify several issues. For example, the cable integrity. Is the cable tightened enough? Is it loose in some areas? Yeah. Is there a connection, proper connection between the cables from this host to the other, or the mast from this mast to the other? Also, the mast integrity. That means the frame of the mast. Is it okay? Is there some sort of corrosion maybe in the mast, and so forth? But also another major issue is the illegal tap off. Some issues which happen that you find some people they tap off from the main grid without being metered by the power supply. So this, of course, this causes a lot of loss because they are consuming what they are not paying for. So through inspection using drones, we can identify all these illegal tap-offs that can happen. Yeah. Another user case is in motor or pump inspection. Now, for instance, there are some issues that may happen inside the motor pumps that they are progressive. If they are not being monitored in the near future, they can cause a failure, total failure, leading to shutdowns. Yeah. So instead, the motor and pumps, we cannot identify any issues regarding to motor bearings. You may find maybe the shaft There's a huge friction between the bearings, causing a lot of heat. So that means in the near future there'll be a failure. And also the motor windings, if some windings are not well connected compared to the others, it causes unbalanced load, which means some of the windings be having more will be carrying more load compared to the other, so leading to failure or overheating. But also, he said that the pumps they are also mechanical seals and so forth. So if we don't monitor leakage, any leakage that is happening, it may cause failure to the pump also. Yeah, you may find after sometimes the pump is leaking or the output is not as per the initial pump specifications. So, and one of the major issues that happen and noticed inside the pumps and motors, it is unbalanced shafts or the movement leading to vibrations. Yeah. So you may find that there's a minimal vibration that cannot be censored by normal, traditional, or manual methods. But droning with the vibration meter which is attached to it, it can measure any unbalanced movement and vibrations at the pipe pumps and motors. So giving an indication that there's a possibility of failure as well. So this is an electrical sector, but also the other sectors, for example, in oil and gas or mining, which you're going to see later. For example, we have confined spaces inspections. Now here we have a special types of drones that we use. And I'm going to talk a little bit about this drone, which is Helios 3. Of course, there are other variants, for example, Helios 2. Now, the main specification of this drone that makes it very good for confined space inspections. First of all, as you can see, it is very compact. That means it is small, such that it can enter confined space and navigate through the minimal spaces without any issues. But also, it is lightweight. So, and as you can see, it is the cage structure. It helps to avoid any crashing between the drone and the other obstacles inside the confined spaces. And also it has sensors in all direction, the six direction to avoid hitting any obstacles. So all this is to ensure the safety of the drones and also the facility. So once the drone is safe, then it can inspect other areas. So the use cases for this drone, for instance, it's as follows. For example, we have tanks. Now, on a traditional method, we used to first of all we used to empty the tank and leave it to vent for some weeks so that there are no fumes inside before sending someone inside. But now we have these drones which they cannot get through all these tank or confined vessels without any issues. And now the major advantage of this is that it saves inspection time because first of all, when we have to use normal workers to get inside the tanks, that means they have to substitute. Yeah. After every minute, they have to come out and another one goes in to inspect. So that is time consuming as well. But drones, once it enters, it can cover a large area without any issues. But also, it is not safe for the workers to get inside the confined space. First of all, it is because of lack of ventilation, but also the product which was inside here. I mean, for example, it was fumes or fuel, so it is not good for the safety of the work. So, to avoid all that, we can use drones to eliminate the risk of compromising the safety of workers. But also, the drones can compile a comprehensive data so that it can help in maintenance. For example, using the drone, it can come back with the data that can generate a 3D model where you can know each and every single defect, its exact location, the size of the defect, And the risk of it, maybe the once the failure happens, what will be the risk of such a failure? Yeah. So using the drone, you can get all this data without compromising the safety and also saving a lot of time, inspection time. So this helps a lot in maintenance as you can plan to perform maintenance in a very short amount of time, but also knowing the exact problem without spending a lot of resources. Yeah. But also we have the culvert inspection. We have the wastewater or sewage drainage systems that you can use drones as well to inspect these drainage systems or pipelines inside the pipelines, for example, for 20 inch diameter pipelines. It is huge enough to receive the drones for inspection inside. So inside these pipelines, we can determine the cracks or corrosion, pitting, any anomalies that we may find inside the pipelines. The geometric anomalies as well, that means the dents or any ovality or any some sort of feature that is not common inside the pipeline. So if it is blockage, you can know which part inside the line is there's a restriction blocking the passage of uh, fluid or media. So yeah, as I said before, the drones they are very superior in early detection for the defects or problem that arise inside the facilities. For example, gas leakage. Now, of course, we have the portable monitors for the gas leakage, but most of them they have a minimal amount of leakage that they can start to detect such leakage. But using the drone gas detectors, which they use the photogeometry to detect the gas leakage, that means the molecule sizes and the shape of it. They detect all this to give a signal that there's a leakage somewhere inside the line. So this helps to avoid major catastrophe, for example, explosion or fire. Yeah, as well as thermal camera. For example, as you can see for the underground pipelines, you may find there's a leakage in underground pipeline, but there's no any sign which has surfaced on top to know that there's a leakage somewhere. But using the drone thermal camera, you can detect the leakage in specific areas which are happening underground, even which are minimal in sense to determine. So using these drones, you can get a lot of data that you can use to for preventive maintenance or corrective maintenance. But also using RGB camera or high resolution cameras, as you can see, there are some areas that we can detect these problems, and you can actually monitor the rate that the features are happening or developing. If there's any additional features, maybe after every 1 week, what is happening inside the facility or your asset. So after analyzing all this, you can using the risk-based approach, you can know maybe if this facility is not being checked or worked upon, it may cause major safety issues. So you have to go and rectify all these issues here. So performing the regular checkups, you will know what is going on inside my facility, what I have to do, and at what rate. Yeah. But also, as I said earlier, drone they help in eliminating risks. For example, working at height or requiring specialists and exposing them to risk environments or working areas. So using these drones, for instance, this is the UT. UT UT tool attached to the drone. As you can see, it can measure thickness of the shells for this tank. It can detect cracks inside the tank or any anomalies on the welding between the shells. So using this, you can easily during maintenance. For example, when you have detected any issues in tank number one, that means you limit the use of such tank and remove all the stock in it so that you can get prepared for maintaining or for the repair of such tank before further usage. So you avoid the loss of the product or any other failure that may occur due to such early uh, problems that arise inside the facility. So for today, that's it. We've seen some use cases for the drone in conjunction with maintenance, how we can incorporate drones for maintenance, our maintenance plans. So that's it for today's webinar. It was regarding the maintenance, improving maintenance for better performance using drone technology. So in case of any question, please don't forget to forward it to our email or my contact. You can contact me personally or email or through any of our platforms. Thank you very much. See you in the next webinar.